Andrew, so since you still believe that banana plants and whales are related, then let me ask you a question, my good friend.
Okay.
Since you've now admitted that genetic entropy is a reality, I'm just kidding. I know you didn't, but you will one day, Andrew. You're seeing it.
Maybe. I cannot deny that possibility. I think it's an unlikely one, but
because you're gonna listen back on our discussion there, and you're gonna be like, back mutations, beneficial mutations, synergistic epistate, none of them work. So I'm just gonna have to tap out, believe the Bible. But no, in all seriousness, we had a good 45-minute discussion there.
Yeah,
so what I'll probably do as well, so Sky, make sure you don't delete this stream. I'll maybe clip that out and just put it up on the channel tomorrow or something for people to listen to.
Yeah, feel free. Well,
something tells me if you're Speed's probably going to see this and we're going to go over this, so that's an all-out likelihood.
Okay, there you go. I'll put it on my channel just to give them some content, because it's probably good for business. So, anyways, in all seriousness, my doomsday friend. If I'm Superman, you're Doomsday. Then, if you're too young to know who Doomsday is, you can Google it. So, since you love phylogenies, which I do too,
30 minutes, guys. 30 minutes. I'm wrapping this up.
What, Sky out? I thought you were going to be here all night.
No, man, I gotta get sleep too. It's getting late over here too, man.
Yeah, you're probably feeling tired too. Okay, well, it won't be that long. I am just curious then as to your thoughts, and I've asked you this before, and since you like phylogenies, how do you what are your thoughts ultimately on the fact that we could look to mitochondrial DNA or Y chromosome, whatever. I asked Rob this the other day, but if we map out worldwide genetic diversity and we see low genetic variation in mitochondrial DNA, we know the mitochondrial DNA is fast in terms of its mutation rate, then why don't we see tens of thousands of mutations here? Why are we only looking at in terms of the mitochondrial DNA, only 100 to 130 mutations, really, and in the Y chromosome, roughly a few hundred.
This is a little advanced for me, a little out of my depth and out of my field. I do know a little bit. I do not believe that what you said earlier, like what a whale became a tiger, became a tree, became this and mutated. That's ridiculous. I do know a little bit about science, but I would say this is out of my field of expertise. But
Well, I was asking Andrew.
Oh, okay. Well, yeah. Go ahead, Andrew.
I wasn't going to try and put. No, I'm not going to try and put you on the spot, Kyle. I don't want to ask you.
You truly are an arch nemesis, SFT.
Yeah, no. I'm not throwing this at you, Scott.
This is over my head for a minute.
You might even.
I want to learn what you're saying, though, bro, so I can understand it. But I don't understand what you're saying. I have to go back and look at it.
Oh yeah, no problem. And that's okay. Well, here's the thing. There's a lot of people, and the last time I spoke to Smokey, unless he changed his mind, I don't know. But there are people who believe in an old Earth, an old universe, but young creation. So this would not be totally contradictory with your position, Sky Out, if you were to hold to that position, an old Earth, old universe, but young, special creation of man. Because all this shows, and all I'm showing to the evolutionists is, okay, we have mitochondrial DNA, which takes us right back to one mitochondrial DNA ancestor, who we'd say is mitochondrial Eve. Okay. And then we have a one Y chromosomal ancestor, who, according to our model, would take us back to Noah, our last Y chromosomal ancestor. That's really all it's showing.
Okay.
And it's contradictory to the evolutionary model, because they want to not only say we're related to chimpanzees, but they also want to take the origin of humans back a couple 100,000 years to millions of years, depending on if we're going back to Erectus or Australopithecines or just the out of Africa. So that's why it's more contradictory to the evolutionists.
Okay. Have you heard of this out of Africa theory?
Yes, and we can get into that, Scout, but I am curious as
Okay.
firstly, Andrew's
Right.
thoughts on this, according to, because Andrew, and here's the last thing I'll say, and take as much time as you want. When I speak of separate ancestry, okay, and this is the topic I've written books on. When it comes to universal versus separate ancestry, as long as I can show, okay, evidentially, that one organism is not related to the rest of the biological world. In this case, humans. I've got a lot of genetic data showing that humans are not related to anything else. They're not related to chimpanzees, who would apparently be our closest cousins. That destroys universal common ancestry, because now you no longer have universal, you have separate, where humans are separate from the rest of the biological world. They're specially created, is my point. Andrew, what are your thoughts? Take your time. I spoke a lot there, so.
Yeah, or well, I guess if that were, I don't feel like that's the case, but if that were shown, I think it wouldn't necessarily show that all other organisms are unrelated, because some we know are related to each other, going back pretty far at least. The other thing I would say is, at least going back to the root of the tree of life, it gets a bit fuzzy because of things like horizontal gene transfer. And that's not to say that we can't figure out those through phylogenetics. It just means that maybe we need a different concept of phylogenetics going back that far.
Well, let's say hypothetically, humans are not related to chimpanzees and therefore not related to anything else. They're specially created. It wouldn't matter even if everything else was related. Even if you still wanted to say pine trees and whales were related, pine trees, whales, and chimpanzees are related, it still destroys universal ancestry, because now all plants and animals are not universally related, because humans are now not in that tree of life. That's my point. All I need to do is really show you one biological organism that has not evolved through common descent, and that not only confirms special creation, it refutes universal ancestry, because you need humans to be related to chimpanzees. You need humans to be in that phylogenetic tree of life. Without humans in that phylogenetic tree of life, you don't have universal common ancestry. Does that make more sense now?
Right. I guess my response to that would be that in that sense, I don't feel that the concept you're referring to as universal common ancestry is really consensus at this point, because it's not at all clear if all life indeed follows a nice bifurcating tree of life. It may be more reticulate in some places.
Right. So let me correct myself. Yeah, let me just correct. Yeah, because even the evolutionists would admit that when it comes to the origin of eukaryotic organisms, or when it comes to bacteria, you have horizontal gene transfer, and therefore at the root or base of the tree, you have more of a bush. I understand that. But higher up on the tree, where you have humans and chimps and old world monkeys and dogs and just mammals and vertebrates, you would say that all mammals are related. I'd imagine you'd say all vertebrates are related. So higher up is where it's less messy for the evolutionists. So if humans are not related to anything, okay, and it's just kind of the human tree, then that would be a huge problem for common descent, would it not?
Well, I guess in this case, if we're I'm not sure how to address that, because I don't feel that we really know what we mean by universal ancestry at this point.
Well, would you agree with Darwin, where he said it's a fact that all life, including plants and animals, should be related?
I lean towards that view, but I don't think that's necessarily the case based on current data.
So would you say there were separate creations, but you don't believe in creation, so therefore separate origin of life scenarios that
I kind of only take it back as far as the root, like I was saying earlier. That's as
Right.
far as I'm going.
Okay, so you take it, but you would admit, as you would agree, as you just said, that all at least vertebrates are related.
Yes.
Okay.
Yeah,
Okay. So
that part of the tree I do think is a clear bifurcating pattern.
so you would agree then, I think, with evolutionary consensus that there's universal ancestry among vertebrates.
Yes.
Okay. Okay. So if we were to show that humans, being vertebrates, being primates, if you go taxonomically speaking, and mammals are then not related to, let's say, other vertebrates like chimpanzees, as in they have a separate ancestry, therefore that at least ruins universal ancestry of vertebrates. That would
I feel like I feel like I get what you're saying, and I feel like I would agree, at least in overall. I just feel that it would be very difficult to show that without going back to phylogenetic methods.
Okay. So now here's the thing. We're looking at phylogenetic methods here. So if we look at I like the uniparentally inherited DNA compartments because they're less messy. There's no recombination for the most part. So I like these types of phylogenetic trees. So my point is, let's look at a Y chromosome then, since we typically focus on the mitochondrial DNA. If we're not seeing tens of thousands of mutations, we're only seeing a few hundred mutations, as would be expected if the Bible's account of independent origins were true, right? Separate ancestry, God created male and female, but inconsistent with the universal ancestry model, at least the universal ancestry model of vertebrates, where there should be tens of thousands of mutations here. Then how do you explain this phylogenetic data according to your model? Are you just going to invoke a massive amount of purifying selection to remove all the DNA differences that should be there, or how would you explain it? What are your thoughts?
Well, I mean, I mostly deal with other parts of the genome and more morphology, for example. So I think at this point, whereas one does not know, one should remain silent.
Right. But my point is, okay, and I've had so many debates on this that I'm confident about it. Mitochondrial DNA phylogeny and Y chromosomal DNA phylogeny of humans, okay, demonstrates that we've only got a few hundred generations max. We know the Y chromosome and the mitochondrial DNA are vastly, vastly, vastly different than chimpanzee Y chromosome and mitochondrial DNA. You don't have tens of thousands of mutations in either the mitochondrial DNA or the Y chromosome. What we find is one Y chromosomal ancestor of all people on the planet, one mitochondrial DNA ancestor of all people on the planet, consistent with special creation. I don't see how this can fit into the universal common ancestry model. What would be your best way of incorporating this into your model then, Andrew?
Well, I guess at this point I would say that it might indicate a most recent common ancestor of these mitochondrial sequences, but it doesn't necessarily indicate the origin of them, is what I would say.
But so would you then put a Y chromosomal or mitochondrial DNA ancestor just a few thousand years ago then, based on the data?
I couldn't say, for example, that is when the most recent ancestor of humans lived, but perhaps I could say that's when the genes coalesce on the tree. Gene trees aren't always indicative of species trees, for example.
Because remember, these are, like, for example, this Y chromosome tree is Y chromosomes, not from just one group of people, subgroup of people, but from all people groups. This is all a reflection of DNA differences, a reflection of mutations over time in all people groups in terms of the Y chromosome here. And therefore, this would be the last Y chromosomal ancestor of all people. That's why we can look to various haplogroups. That's why I typically point to the HVR haplogroup here on the mitochondrial phylogeny. This is the most common one in Europe, and how we have evidence of people picking up more mutations in the exact same amount of time because of the length of the branches. So that actually ruins the evolutionary molecular clock, because if we have the same people living at the same time accumulating more mutations than, let's say, their cousins, then we can't really make assumptions based on when humans and chimpanzees, when their last common ancestor split, and then base our mutation rate that way, right? People like Dan, they want to look to what's called the substitution or phylogenetic rate, and they want to essentially base it off a much slower, not really a much slower mutation rate. They'll at least acknowledge that the mutation rate is fast, but they'll say that most mutations are lost, and therefore purifying selection has removed most of the mutation rates that essentially should be there, which I agree with. By definition, the pedigree-based mutation rate is faster than the substitution rate or the phylogenetic rate, because obviously a lot of mutations are weeded out over time, right? But even considering that, even considering massive amounts of purifying selection, it's like we're still looking at such low genetic diversity. And then, Andrew, as I pointed out before, the Y chromosome dissimilarity right here of humans and chimpanzees. Look what David Page said. The Y is full of surprises. The Y chromosomes of chimps and humans is horrendously different from each other. Horrendously. So it's not just a little different, it's a lot different. My point is, to sum it up, this is a problem for universal ancestry in terms of at least vertebrate ancestry. So I don't know. I don't want to beat a dead horse.
I definitely have to look into that.
The horse is still alive. SFT. No, I'm just kidding.
The horse. All right, I'll beat it a little bit more. I'm just kidding.
Finish him off. No, I'm just kidding.
Finish him.
He's just.
You know what? I want to save this horse for future discussions in the future. I'm going to leave him just barely alive, let him heal, and then come back for more. Then we'll beat him for good.